We have a new SCARA that launched last year, so we're still promoting that one. But this year in specific, we're actually launching our Integrator Program. So we want to work more directly with integrators throughout the US and Europe. And that's something we'll be promoting at the show.
That is excellent. I'm a systems integrator myself, and I'm actually very interested in this program. And I'm curious what the program would offer to integrators as far as, say, training.
Yeah, so there's going to be free advanced training for integrators as well, most likely up in Montreal.
Awesome.
So you could come up there. Also, we want to just work closely, make sure that there's no hurdles for integrators. So when our customers request to work with our robots, that, there's nothing scary about our robots, right? There's some integrators that are still not familiar that A, we exist, and B, that our robots are actually quite easy to integrate and deploy as well.
So we were talking about just how light these robots are. Yeah. So before I actually get to that, let's talk about the payload and the reach for these guys.
So the rated payload is 500 grams. The max payload is up to about 1 kilogram. We have a repeatability of 5 microns at the rated payload as well. And the reach is 330 millimeters on the 6-axis robot.
So when we were talking about the reach being a little bit small, but that not being so much of an issue for you guys, because how much does this robot actually weigh? So
the total weight of the robot is about 4.5 kilograms, which means you could really easily mount it on a linear axis and move it around.
Right.
And then, because a lot of the applications that we work with are high precision, these linear axes or guides can be, 1 micron in terms of repeatability. So you still have a package that has a lot of range, but is very precise.
So the other thing that I think is an interesting possibility is being that the robot is less than 5 kilograms. It's totally possible to mount this robot to still another robot. And
yes, I mean, I haven't seen deployed application of this, but we've seen a lot of trade shows where our robots mounted to the end of a FANUC, for instance, as well. So then you have a 12 degrees of freedom robot, which is interesting to see.
Well, I would love to use a 12 degree of freedom robot to do things like inspect hard to see things and just get into harder to reach places really with a small tool. But outside of that type of application, what are some ideal applications for a Mecademic robot?
There's really 3 big industries that we work with. Medical device is probably one of our biggest ones. I mean, they have a lot of tiny parts. They have a lot of high volume production as well. Then we do a lot of consumer device. So anything that you're wearing or is on you, so your phone, tablet, wearables, AR, VR goggles. This is some of the core of what we do. Another big industry that's coming up is optics. So we do a lot of optics and photonics in terms of optical alignment. So laser manufacturing. So we work with SpaceX, for instance, on some of their laser communications as well. So we do have, those are the core industries, but we do some automotive, but mostly, testing for touch screens or steering buttons, window buttons as well. So a lot of automotive testing on the electronic sides or connectors, for instance. There's also watchmaking in Switzerland. Again, small, tiny parts. That's what we're specialists in. Yeah.
So this 5 micron repeatability is pretty big.
Yeah.
We were just discussing outside the booth that you guys, most of the time when we're talking robots, we talk about repeatability, pose repeatability, but we don't always see accuracy because there's some things involved there. But you were describing to me that Mecademic actually can cite an accuracy, and it's pretty impressive.
Yeah, so we've been developing something for the last couple of years. So as we're very good in repeatability, 5 microns, but a lot of our customers, especially in optics, they requested high accuracy applications. And because the robot is so small, we're actually able to place it into a CMM machine, do our measurements, and do a standard off-the-shelf accuracy calibration, which means that we're able to get around 100 microns of global accuracy in the robot's workspace. And that's something that's basically off the shelf. So when a customer orders it, they're able to check mark it. So it's not as tedious as, having to do it on site with laser systems. So we're able to compete well with that. Yeah.
So as we increase payload, because you were telling me that it's rated for 0.5 kilogram, but it can go up as high as
1 kilo.
1 kilogram?
Yeah.
And how does that affect the overall
so
repeatability?
we're going to have a better warm-up time for the robot in terms of trying to get to that 5 microns. So it's going to be maybe closer to 10 microns with the kilo, but that's after a little bit of a warm-up. So it's like anything else. If you put something heavy, there's more deformation in the product, so you have to compensate for that.
So even as you double the payload, your repeatability is still at 10 micron.
It's still very good. It's better than what a lot of people need.
So if I were to start this integrator program with you guys, and I have a customer that wants to use one of these right away, and I'm struggling with it, you guys have support in place?
So especially with our advanced training, we're also actually going to help you how to optimize it in precision applications. So we have a good team. We have people who are really experts in precision applications who have worked with the optics industry and electronics, and they're able to guide our integrators into how to best use our robots for these tasks.
Excellent.
Yeah. And I know a lot more about PLC than I know about robots. And I was in your booth once, and you had, I think, the record for like the most robots in a booth. But I also saw like you were spinning little signs of all the different protocols that you could connect with. Yeah. Can you talk about like the history of that and like how many protocols you can support now? Yeah.
So when the robot was first developed, we actually just had TCP/IP, so it was very easy to use with Python and C# and LabVIEW software protocols mostly. We also very quickly came up with EtherCAT. We worked closely with Beckhoff on that. And then we found out, the majority of the U.S. customer base uses Allen Bradley. So to work with them, we developed Ethernet IP. And then same thing, as we've expanded in Germany, we had to develop Profinet. Now, the difference is that every single robot that we sell natively supports these 4 protocols. So it's just a software command to change which one you're using. So there's no additional packages or anything that you have to get to be able to use it with them.
Very cool. And then what is that record for that amount of robots? Because there were a lot, at least 2 years ago.
I think we had something like 40 robots in our booth. Yeah, we've scaled it down a little since then, because that was a bit tedious to program all of them for a trade show.
You bet. Oh, I can't.
But it was definitely fun. Yeah, we had 40 robots in our booth. Cool.
So I'm curious, do you guys have kind of like an ecosystem for the end-of-arm tooling, or do you have a lot of partners that create tooling that's doesn't eat into that payload?
Yeah, so when we started, it was harder to find partners. Now there's more and more smaller components. So we work with Shunk on our gripping technology, for instance. So we have a partnership with them on our very compact gripper. We work with Boda sensors in terms of the force control. Same with ATI. We work with them as well. There's a lot. If you go on our website, there's a few that we could refer you to. We have, tool changes from Cosmec, for instance, as well, that they make very small ones that fit our robot very well. And then there's other accessories we could find in terms of, I know Atlas Copco makes small screwdrivers that fit very well with our robots. There's quite a few.
Excellent. Can you talk about the, you have a new SCARA, because like typically you had the 6-axis micro robot, industrial robot, but when did you come out with the SCARA, and then what are the specs on that? Like how fast? I imagine it's very fast.
So yes, the SCARA is made more for some more simple, faster pick and place applications. So the goalpost tests were about 0.42 seconds on that one. So it's faster than the Mecha 500 and some 6-axis robots as well.
What is that thing called? The SCARA?
So it's the MCS 500.
Okay.
Yes. And it's also actually I think the world's only symmetrical SCARA. I call it symmetrical, but it's basically the only SCARA that could be mounted both on a table and upside down without any hardware change.
Wow.
And when you mount it upside down, you actually get the full 360 of work area under it. And the main reason we built the SCARA, though, is a lot of our customers, they love the Mecha 500, but they didn't need the 6-axis. They were just doing simpler pick and place, but they love the compact packaging, the form factor. There's a lot of integrators also that actually requested it. And we're mostly competing against integrators designing, their custom Cartesian systems. So, they have a lot of engineering time to do 3 axes and another rotation. So a lot of our competition is actually custom designed Cartesian systems. And that's where we fit in with our Mecha and SCARA.
I mean, you're probably a lot more flexible than that custom designed thing.
Yeah, exactly.
You can redeploy that robot to do other tasks.
Exactly. So you could use it for one task one day. You could change it around. A lot of our software is included. The protocols are all included. And we're like, what we've noticed is one of the few robots that are used in both process development, so R&D teams with the company, and then actually deployed in production, because the R&D teams, they're just using Python and whatever else that they need to use it. And then they're deploying it with Ethernet IP, for instance.
Okay.
Is there more than one size of the 6-axis, or is it just one standard size?
Right now, there's just one size of the 6-axis, but we have other projects in the works as well.
Cool.
But we're not, our niche is really compact, high precision robots. So we're not necessarily going to be making a 5 kilo, 10 kilo robot anytime soon.
Makes sense. What about, you told me about sleeves. So like what kind of,
So we have, there's dust-proof sleeves that you could get for the robot. You could also get like an IP65 rated sleeve if you want to put it in like a machining center. A lot of our robots are actually mounted inside of machines. So if you're thinking of like a laser marker, for instance, our robot could be actually inside the laser marking machine. So you could put a pallet of parts. It picks up the part, marks it in different orientation, puts it back. And that same thing with like loading small CMM machines, small machining centers.
So small.
Yeah.
I'm not going to lie, you blew my mind out there when you were talking about putting it inside a CMM.
Yeah.
Just the fact that it can go inside of the machine that it's tending versus other robots that have to sit outside the machine and reach into it. Some of these machines, that we were talking about are for medical device. And you had mentioned that it's already kind of a fairly clean robot. Is there anything specific that has to happen to this robot for like Cleanroom or things like that? Or it's already pretty?
The Mecha 500 is actually, we had it rated by Fraunhofer. So every single robot off the line is ISO 6 level compatible. Okay. And that depends how you use it. So that's just the base level. So depending on how you move the robot, most of the particles are generated by the last joint, spinning at full capacity. So if you're not doing that, you could meet certain levels like ISO 4, for instance. So we've met most medical device requirements on that.
So this is not a collaborative robot, even though it's small. What can you talk about safety and the guarding like that's required for that?
So, we focus the robot as an industrial robot. It is sort of, I would say, safe by design a little bit because it's, we don't use a lot of power. Our robot's using around 30 watts. Wow. Because of the design of the robot, it's still an industrial robot. And we also focus on high precision applications where collaborative robots don't always fit in, right? So they're usually less precise. We're very small micro industrial robots. That's where we fit in.
I imagine the risk assessment looks like the robot falls. If you overload
one of the highest risks with the robot is actually carrying it because you could drop it on your toe. So that's what they pointed out to us. But you are able to stop the robot by hand if it's going. We're monitoring the torque on all the joints. So like early UR robots did the same thing. But in general, we're not promoting it as collaborative. This is a fully industrial, high precision, high speed robot.
Right. And it's application specific now. We don't call the robots collaborative. Oh yeah, it's a power and force limited robot, right? Mm-hmm. And you said it's a 30. I'm making sure I understood you right. That's a 30. You said 30 watt robot.
So during normal operation, it'll spike maybe to around 75, 100 watts during acceleration.
Right.
But in general, it doesn't take much more than a laptop.
That's what I was just thinking. My laptop and my computer monitor draw more power than that. That's pretty insane. Okay. Do you have any systems like that running off of, say, battery power? Because
we've had that. Battery backups are very easy to do with the robots as well. So, for any integrator, I always recommend to have a battery backup for the system.
Yeah.
We work with a lot of very sensitive parts. So you want to make sure that if there's a power failure, you still have enough time for the robot to go and drop the part wherever it needs to be dropped. We've had battery applications. We don't put them on AMRs as much just because the reach is not there to pick up packaging. But there's some other applications that we've done.
Can you talk about you said that you're using them in labs. What kind of things are they doing in these labs?
So part of our market is actually lab automation as well. So not so much for automate, but we are handling, microplates, dispensers. Again, a robot is simple enough that, the scientists in these labs are not intimidated by it as much as they would be by a much more bigger robot with a separate controller, with a lot of, let's say old school programming ways. So for us, they're able to integrate it with most of their software is in C#, I think. So they're able to integrate it very easily with their software.
What does that development environment look like? Because do you guys have a teach pendant, or do you have to connect to it through a laptop?
No, so really the robot is the robot itself. The controller's in the base of the robot.
Okay.
We have a small power supply that comes with it. Now, we have a web interface, which we call the Mecha portal, which runs inside of that controller. So any PC or laptop that you could connect to it is basically your teach pendant at that point. And then after that, you could integrate that same code with your own Python. We have a Python API, but you can use your own, the C# driver that you could use, or C++, or you could program everything on the PLC side as well with the industrial protocols.
Or make an HMI your teach pendant.
I was just going to say that you speak all the protocols, so theoretically I could use an HMI.
And there's a lot of integrators that prefer it that way, that all of the control is on the PLC side, and in some ways it becomes like a 6-axis positioner. And we are doing all the motion control and the kinematics, so you don't need any complicated PLC to run it. So very base level PLCs could control multiple robots.
Do you already have, or are you thinking about putting out like, modules for these, like what are they called? AOIs, like on,
Oh, they're already out.
There's already out? Okay.
So
Nice.
we're very open. So if you go on our website, you don't even need to log in right now. So just download the AOIs, try it out.
Oh, nice.
Yeah.
Okay. So
we have examples for a good 10 different PLCs, I would say. We have Omron and both Ethernet IP and EtherCAT. We have Beckhoff and Schneider, even Codesys, Allen Bradley, obviously. Quite a few. Yeah.
Interesting. If I had a project and I wasn't sure if the Mecha was the right fit for it, do you guys have a program where an integrator can borrow one for a week or so and experiment with it?
Absolutely. So we do have a loan program. We also have very highly discounted units as part of this integrator program that they could use internally for POCs. And, they usually like it because it's also good for trainings. It's portable. I mean, you could take it in your carry-on if you really want. So,
all right.
So we're going to work with integrators as much as we can. There's some tests that we could do on our side as well in terms of proof of concepts if they need some assistance, testing a specific process.
So for those of us that are definitely interested in this integrator program, how can we get in touch with you?
So one way is through our website, but since you guys are at Automate, booth 4800, and we're actually having a happy hour today from 3 to 5 specifically for integrators, hot dogs and beers if you guys want to stop by.
On. I'll go for a hot dog. And for those of our audience that maybe aren't at Automate, how else can they get in touch with you?
So either through our website, there's an integrator program, just say contact us, and it goes to me mostly. You can also contact me on LinkedIn as well.
All right. Yeah. Well, I appreciate your time. I'm a robot nut, and I think you guys have a really cool product.
Thank you so much.
I appreciate talking to you about it.
Thank you.